Hello, everyone. Happy Saturday, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight are three of our students who work at the Planetarium. I will let them all say hi and introduce themselves, and we will start with Eli.
Hi, I'm Eli. I'm a physics and astronomy student at UMD.
Hi, I'm Len. I'm also a physics and astronomy student at UMD.
Hi, I'm Allie, and I am a biochemistry student at UMD.
Oh, that reminds me, Allie, there's something I wanted to ask you about. Maybe I'll do it on stream later. And I can't remember what it was now. Oh, it was some other form of life that produces oxygen that's not photosynthetic. Did you see that?
I did not know.
Okay, we'll chat about it later, and maybe I'll bring it up on stream later. Sorry,
Cool.
it just occurred to me. I was like, I had something I wanted to talk to Allie about. That was like astrobiology.
Cool, I want to hear it.
Sorry, completely sidetracked. All right, so back on track. Thank you everyone for hanging out with us tonight. We are going to be doing a tour of the solar system, so taking a close-up look at the planets in our solar system, a few of the moons, not all of them though, because we have an entire show that we do that's looking at the moons that my guess is we'll probably do next month, just thinking of how we normally stagger these shows. All right, so as I get everything set up for our solar system tour, as always, if you have any questions throughout the show, feel free to leave them down in the comments. Eli is going to keep an eye on that for me and will let me know if questions come up. If we don't get to them right away, don't worry. We will make sure that we take time at the end to answer any of those questions that we missed. All right, so we're going to switch us over to our solar system view. Gonna pin myself so that you guys can hide while I am doing the solar system tour. All right, and here we go. So we are starting off looking kind of down at our solar system. We see, of course, the sun there at the center, and we have the orbits of the planets turned on, because if I have them turned off, you can very easily, or maybe not so easily, tell where the planets are. You can easily see that the planets are very small and kind of get lost in space. So we leave these orbits on to kind of keep track of where things are. But you can see just how small the planets really are compared to the sun and the other stars out there. You can also see a big difference in how they're spaced out. Our outer planets here are spaced pretty far apart from each other, but as we get in, those inner planets are very close together. All right, so to start off our tour, we are going to go to the very center where our sun sits. Our sun is a star, just like the stars that we see up at night. It's just a lot closer to us, which is why it looks bigger and brighter than all of the other stars. Since our sun is a star, that means it is a big ball of hot gas. And you can see on the surface of the sun, there are these kind of darker spots. These are very cleverly named sunspots because they're spots on the sun. They look a little bit darker than the rest of the surface because they're a little bit cooler. Now, they're not cold. So, on average, the surface of the sun is about 10,000 degrees Fahrenheit. Those sunspots, they're about 7,000 degrees Fahrenheit. So still very hot, just, a little bit cooler than the rest. And they do look like they're pretty little. But to give you kind of a size comparison, this sunspot, can you see? Can't see my cursor super well. But this small one kind of left of, or right of center, this sunspot is about the size of the Earth. So not really little either. Okay. Now we are going to go start visiting the planets. And we're going to go in order from closest to furthest. So the closest planet to the sun is Mercury. And there we go. So Mercury, a lot of people say look like our moon, and you are not wrong if you think that. It does look very similar to our moon, and that's because they are very similar objects. Both Mercury and the moon are small balls of rock in space. Mercury is a little bit bigger than the moon, so Mercury is about a third the size of the Earth, while the moon is about a fourth the size of the Earth. But they are just big balls of rock. And if we look closely, we see that the surface is covered in these impact craters, which of course happen when something hits the surface of Mercury, and that could be an asteroid, a comet, a meteorite, anything like that. And when it hits, it explodes, and that explosion carves out these circular craters. And Mercury's surface is covered in these craters. And that's because there is no process to erase them. Here on Earth, we have running water and blowing wind. Both of those create erosion, which would grind down the surface features like craters. We also have volcanoes and plate tectonics. All of these types of things constantly change what the surface of the Earth looks like. Mercury doesn't have any of that. So when a crater forms, it stays there until something else hits Mercury, and that might disrupt the crater that was there if you have something hitting right on top of where a crater was. So we see lots of these craters all over the surface because of that. Now, Mercury being, of course, very close to the sun is very hot. The daytime temperatures on Mercury can exceed 700 degrees Fahrenheit, getting up to almost 800. But notice I said daytime. That's because nighttime gets frigid. And this happens because Mercury does not have an atmosphere. Atmospheres act like a thick blanket. They trap heat, and that helps the night to stay warmer without the constant heat from the sun. Well, without that, the night side cools off very fast and gets extremely cold, with temperatures dropping down to like negative 200 degrees Fahrenheit. So we have a kind of dichotomy here. We have the really, really hot daytime and then the frigid night times. And that is Mercury. All right. So we are going to head on now to the second planet from the sun, and that is Venus. Now, Venus for a long time was kind of nicknamed Earth's twin. And the reason for that is at kind of face value, it does kind of similar to Earth. So it's the same mass as Earth, roughly the same mass. It's about the same size, the same diameter. So we think it's made of the same types of materials that Earth is made of. And of course, when you look at it, you see lots of clouds. And Earth has clouds. And that's about all we knew for a long time. But that led people to speculate that under those clouds there could be something Earth-like. Now, we always expected Venus was going to be a little bit hotter than Earth, since it is closer to the sun than Earth is. So most of the time, what was kind of speculated about the surface of Venus was a kind of hot, steamy rainforest or jungle type of scenario there. But we couldn't figure that out because these clouds are so thick and always present. We can't actually see what the surface of Venus looks like. At least that was the case until the 1960s, when we developed radar. And radar is able to travel through those clouds and bounce off of the surface and let us map what the surface looks like. And that led us to seeing what Venus is like. And it turns out that this is nothing like Earth. Venus is, in fact, the hottest planet in the solar system, hotter than even Mercury, with temperatures on Venus day and night reaching almost 900 degrees Fahrenheit. That's hot enough to melt metal. And the reason it is so hot and stays hot all the time is because of those thick clouds. Remember, I said clouds in an atmosphere act like a blanket. Well, Venus is such a thick cloud coverage and such a thick atmosphere that it traps so much excess heat, and it has what we call a runaway greenhouse effect. And that has led Venus to becoming the hottest planet in the solar system. Now, other than that, there are some similarities, and by that I mean Venus has volcanoes, just like Earth does. We think Venus's volcanoes are active, but we're not 100% certain on that. But we do see volcanoes. In fact, these kind of lighter areas that you're seeing, these are actually where we had lava flows that flowed across the surface. So we see volcanic activity, and then that's about it. We don't see plate tectonics on Venus or anything like that. And of course, it's so incredibly hot that nothing can really survive on the surface. All right. Heading now to the third planet from the Sun, which is our home planet. So it's the one we, of course, know the most about. Looks quite a bit different than the other planets we've seen so far. Earth is pretty unique in a few ways. One of those being the abundance of liquid water that we have covering our surface. We don't see that in any other world in our solar system. We, of course, also have an atmosphere. We do see that in other places. We just saw that Venus has a thicker atmosphere than Earth's. So the other thing that makes Earth unique is, of course, us, life. We have life here on Earth, which we have not yet found anywhere else. Now, one other thing that Earth has that we haven't seen yet is a moon. Mercury and Venus do not have moons. So this is our moon, which is just the moon. I've been asked a few times why our moon is just the moon and other planets' moons get like fun names. And I haven't been able to find a satisfactory answer other than just we knew about ours first, so it was just the moon. And then when we started finding others, we started giving them names associated with the planets they're around, or I don't know. I don't know if any of you guys have heard anything else, but I haven't found a satisfactory answer for that one yet. But I think it makes sense that, ours was the first. So moon looks very similar to Mercury. One big difference you'll notice is the moon has these dark splotches. And these are what we call the lunar maria. Maria is Latin for sea, a body of water. These are not water, but they stem from a time back before we had telescopes. When people looked up at the moon and saw these dark patches, they thought it looked like water. So that's what they called them. They called them the mare, the seas on the moon. Now, we know that that's not the case. These are actually rocks. And the dark color is because they're a type of rock called a basalt, which is it is the same type of rock you would find in like Hawaii or any volcanic regions. It's a volcanic rock. And so that tells us that these dark areas are ancient lava plains. So sometime in the past, probably about 3 billion years ago, the moon was still hot enough to have molten rock under the surface. The surface got cracked open, probably by just being hit by lots of stuff. That lava welled up to the surface, spread across the moon, where it then cooled and solidified and created these dark patches of the lunar maria. And one of the reasons we know that that's kind of what happened, not just because they're basalts, they're lava rocks, but when you look at the mare compared to the rest of the moon, we see that the mare don't have nearly as many craters. So that tells us it has to be a relatively younger piece of the surface. And what happened was when that lava flowed out and covered the surface, it filled in the craters that were already there, very much like we pave in potholes on the road. And so it smoothed out and kind of renewed the surface. And because it's relatively younger than the rest of the moon, it just hasn't been hit as much since it hardened and solidified, so we don't see as many craters there. All right. So we are going to head off now to the last of, yes, the last of the rocky planets. And we are heading over to Mars. Mars is nicknamed the red planet, and you can see why. It is red in color. That red color comes from rust, iron oxides, which cover the surface, giving it that rusty red-orange color. Now, a lot of people are surprised to hear that Mars is actually a relatively small planet. It's only about half the size of the Earth. But we do see, you can see down here, polar ice caps, like the Earth has. You can't really see the northern one that well right now. And these polar ice caps are, some of it is frozen water, but a lot of it is also frozen carbon dioxide, which is pretty cool.